Okay. Alrighty, folks. Hi there. I had a bit of a delay, but hopefully we're all good now. I still have some... I look like a ghost in front of the moon. What? That's cool. Maybe it appears as if I'm dead. In many ways, some of us might feel like we might want to be dead right now. That's not a great time. Don't I? There's plenty of stuff to look at in the stars. Unless it's cloudy, in which case I'm here, and we'll look at some stuff in Solarium. Yeah. But here's the thing: the moon's out tonight, and it looks pretty good. The funny part with like a moon that's out and it drowns out a lot of the fainter stuff you can look at in the sky. If you're all beginning to stargaze, the moon's awesome. And there's this period where you might get used to the moon or you don't like it because it washes out galaxies. It's a pretty big source of light pollution. But it's very useful and it always looks cool. I like looking at it. Even now. Some people make a whole thing of looking for individual craters and marking down weird transient phenomena that they've seen. Some people record it to get a meteor strike or two, which is very rare, but you get something once in a while and it's pretty neat. But we're going to talk about today into a few different instruments, and I'm going to also walk you through that on Solarium as well. And if you've never used Solarium, it's free, it's open, and it's on pretty much every platform. You may have to pay for it on smartphones, I'm not sure, but just go to solarium.org. It's a great little program, and you can really customize the heck out of it. And I'm actually going to be trying to learn some keyboard shortcuts on it tonight too, since I'm going to try and make this a little more slick for everyone. First, we're looking at our instruments. So, sorry, I don't have multiple monitors, so I'm juggling script, which is not really. Here is my magnificent script, by the way. I'm a real professional. This is a reminder. Anyway, yeah. So, if you're glad you already got spoiled by everything tonight. First, looking at the moon. The first thing you do when you want to look at the moon, if you haven't really looked at it at all, and you probably have, but if you haven't, here's the number one instrument to use right here. It's your eyes. Now, if you don't have eyes, or you're blind, there are actually ways to check out the moon. There's sonographic stuff, where they've done different craters and seas and stuff with a sonography kind of thing where you kind of trace. It's an oral representation of the sort of the topography of the moon. Those are actually pretty neat. And same with that goes for there's Braille moon sets too. There's a Touch the Moon series of prints from NASA, which is pretty. I don't think they have it easily available anymore, but you can track this down on eBay. A few, at least a couple dozen space objects. A lot of it's on the moon, where you can just sort of feel the surfaces and stuff. And they try to represent other things too, I think the Orion Nebula's in there. So that's called there's a thing called Touch the Moon, which has that. But look it up. Touch the Moon, I think, is one volume, and then there's a Touch Space or something. I'm sorry, I'll get that ready for next time. But look up Braille NASA stuff. They actually do a lot of cool stuff there. So anyway, visual. Number one, if you're looking at the moon and you want to see craters better, just literally wear sunglasses. I'm not kidding. They cut down on a lot of glare, so you can actually see a lot more with sunglasses for very bright things at night. So if you're looking at it through a telescope too, or binoculars, you can literally double this up and just look at it. Then you don't have to get filters. those can be a little pricey at first too. So yeah, just you've got your glare protection here. You don't have to do it. But sunglasses on their own, actually you can see a lot of the moon better. Maybe even pick out a couple of the larger crater Copernicus shockingly well. And when you think, I want to start out in astronomy, I want to do some stargazing, the moon is a great target. You learn a lot just by looking at that, and you don't have to break the bank getting anything at all. You can just use your eyes, get some sunglasses, and there's your sunglasses. Next up, of course, binoculars will reveal a lot more. And I have these 10 by 50s. I really like these. These are Nikons, and I got a good deal on them. They're less than $100. 10 by 50, those two numbers mean the 10 and 10x, 50. 10 means the amount of magnification these are doing. So I'm seeing it 10 times bigger. And 50 is like the field of... No, sorry. Well, it's the size of the lens here, which is 50 millimeters wide. Or a little under 2 inches. It's not 2 inches. I can't go through these units very well. A little more than 2 inches. I just moved into a new house. I have this everywhere. Scopes you strap on your face. And you can also look at birds in them. Or your neighbors if you're a creep. Lots of other stuff. I actually have to, when I move to a new place, I gotta go tell neighbors. I'll be outside stargazing. I'm not a creep. You can come over and stargaze with me. And I get to hang out. Not now, with COVID time, but in the future, hopefully I can check in with the neighbors. I have another pair of binoculars actually here. Kind of funny enough. So I use these a lot, but these are actually my preferred traveling ones, and these actually a lot of people might have something that looks like this more than these. These are both good, and they both make stuff look really good. These are 8 by 42. These are by Celestron. They're about $100 too, I think. Maybe they're a 60. But yeah, Outland X's. You can get all kinds. These are actually more birding. They kind of have this style more, the straight tube. But they travel way better if you're trying to save on space, and you still see stuff pretty well. The field of view is a little narrower, but it's way lighter and more comfortable to use for a lot of people. So, anyway, a lot of people have binoculars lying around, and people say, Dave, what's the telescope I should get? And the answer is binoculars. Whatever you have lying around, even if you have like a little kid pair or something with like Play School written on the side or whatever. I don't know if Play School still exists. Those are totally great. Use those. Just to start. You can still see cool stuff. And not just the moon, but like Jupiter, you'll pick up on the moons real quick with binoculars. You might even be able to pick up on one of the moons of Saturn with binoculars if you're real good, and that's called Titan. Venus with it. You can pick out Mercury and Venus in early morning or early evening right after the sunset, and you can't quite see them yet, which is a neat trick. Galaxies actually work a lot better in binoculars in a few instances, like the Andromeda Galaxy under a dark sky sight, because it's very big. Anyway, binoculars are great. Don't use binoculars to look at meteor showers. Use your eyes. Oh, so the other thing we're going to look at is what does the moon look like in naked eye, binoculars, and telescopes. And I got two here that I've set into Solarium, which will let us see what it looks like with those as well. My favorite little telescope is this one right here. This is by Astronomers Without Borders. And it is not too big. See? It's 2 human heads high. This is, the aperture is 130 millimeters. It's about 4.5 or 5 inches, I think. It's a reflector telescope, means uses mirrors. You can think of the binoculars as refractors, like the ones with the lenses. Neat thing with this, it's very portable too. It's a lot lighter because it's a little lab telescope, eh? But this thing is nice because you can also, it stores real good. So you can see you can expand it, travel, contract. It's great. It's called a tabletop setup too. It's made to sit on a table or something else. Like hood of your car, that kind of thing. It's one other telescope I programmed into it. It's not a little one though. I don't know. I haven't actually tested the framing of this. My house is dirty. I'm sorry. This one here. Take you off for a second. Alright, so this one here is about 12.5 inches wide mirror. It also does the same thing as that other telescope. It expands and contracts with storage. This is a lot bigger. This is about 12.5 inches. Very fun to use. Pain in the butt to move around now. So, also the base of this seems to bang myself in the shins every time I move it more than several feet without a wagon. So, bigger telescope will see a lot more for sure. Drawbacks, which means that the thing I use the most out of everything in this house, it's honestly these. They're the lightest and I carry them everywhere. And then it's this. I can just set it up in a couple seconds. Think I would use the biggest telescope the most, right? And I know. Anyway, let's take a little trip into Solarium for a couple minutes and you'll see what the moon looks like in a few different views, okay? Focusing. I'm going to improve the webcams next. Anyway, here we go. Let's do Solarium. It's launched. Alright, let's see here. I'm going to transition. Hey! Awesome! I'm so getting used to all of these things in the studio. Yes, I need a wider view. Webcam. Higher resolution. This is like 8 years old. Dang. Anyway, we're in Solarium. Let's check out the moon, shall we? First of all, let's get the time setting right here. So, yeah, where are we? What's the time? Let's get this to today, eh? Just let's advance an hour, eh? Let's do it's Friday. It's 10:30, right? We're gonna go out. We're gonna look at stuff. Bright right now, as you can see here, right? It's gonna be rising in the southeast. Yeah. Now, I'm going to click on the moon. It's probably going to look really cool rising as you're waiting for it to emerge. Naked eye, you're going to see a little more than this. I think it's kind of funny that Solarium is blurring this out, but it's very close to full. Naked eye, I'm seeing like just a little hint of the seas. The seas, you know, those are like old volcanic lava flows. The bright stuff is where all the craters and mountains and stuff are. That's an interesting thing looking at the moon too. Dark stuff, old stuff. Bright stuff, newer stuff. But, you know, with binoculars, you can see a lot more. And here's what I want to show you. So let us look at, we're going to check out the ocular view here in Solarium. This helps you preview what things are going to look like. It's kind of neat. So, take this back some. Yeah, there we go. So you got a little preview of what things are going to look like already, right? But the moon right here. This is, I've programmed it to do a preview of what it looks like using these binoculars. Now, here's a weird part about binoculars versus every other astronomical instrument. This actually doesn't completely satisfy what the view is going to look like because your brain is going to take 2 telescopic images and merge them in your head. Since you have literally 2 little telescopes, there's double the light gathering ability, and it actually looks more impressive than it does here when viewed through binoculars. Like, the view, like, personally, and this is not scientific, but my own impression is that the moon with 10 by 50 binoculars tends to look better and more detailed than, say, the moon through a 60 millimeter telescope. Still a good view through the 60 millimeter telescope. 2.5, which is roughly 2.5 inches. It's usually, those are the refractors you see. Like, if you know, like a small starter telescope, your idea in your head of something little and long and a tube and it's like 3 little tripod legs. That kind of telescope, your starter one, roughly equivalent to one of these in a way, maybe a little better. But 2 of these are better, in my view. It tends to bring stuff out a little more. These are also great to go out with your big telescope because you can look at stuff with these and then point your telescope towards it for the magnified or richer view. So anyway, that's my little qualm with how the view appears here. Your mileage will vary according to how your own vision is and your comfort with the binoculars. So, moon's looking pretty good with binoculars. You can make out a few highland details. You got some like all these seas here are popping right out. You could draw a little picture and show all the major seas, which would be cool. But say you want to bump up a little bit, you're gonna use this little telescope here. Yay! Okay. And also I programmed. We're gonna go through the first two telescope previews using this, which is the eyepiece. You swap out eyepieces in the telescope, say, and when someone says a telescope has X power, this is what determines that power. Magnification is concerned. The ultimate determination of how powerful a telescope is the quality of the mirror or lens inside of it. This does optical stuff that the final calculation about how much magnified it is. Because you can swap these out, so you can have a view in a telescope. It's not like 100 times. You can have 400 times, 50 times. Myself, I usually look at galaxies and like the moon and planets. So a lot of times, I'm usually at 100 or 200 magnification. If I get a good planet view, I like to magnify a lot more. But yeah, that's one thing someone might not understand is you might not want to magnify a whole lot. I'll show you. Here's the moon now with, ooh, that's a big boy. The one sky, that 5-inch telescope there, the smaller one. This is the view with, there we go. This is the view with a standard 32 millimeter eyepiece. It's a lot than the binoculars, eh? So yeah, we're getting a lot better. This is kind of nice. And plus, unlike binoculars, telescope points at it and you can look away. Now it's going to slowly drift if you don't have a motor on the telescope, but it still takes a while to trudge along in this view. Like we're not magnified a lot. If you wanted to magnify more, you'd swap with something else like this 15 millimeter. Saying we're going to do that right now. Boom. There we go. Craters a lot more obvious now, aren't they? In fact, that image I had in front of me, I took that picture. Well, the image I had behind me, let me switch back in OBS here. Transition. You see this here? I took that picture with just an iPhone camera, like an iPhone 6, through the little telescope and this. Wait, the big telescope and this. Sorry. This is definitely the bigger of the two telescopes. Great pictures. Actually, you know what? This might have been with the little telescope. Now I'm thinking about it. Anyway, you'll see what I mean in a second. Like I said, if you want to do astrophotography, get your phone and a little telescope, even through the eyepiece of binoculars. You might be asking, I want to see what the big telescope's going to see. Alright, so let's bring the eyepiece back down. Okay. Now this is the difference between a big and a little telescope's field of view, right? Boom. This is what the Skywatcher, that big one, that 12.5 inch, that's hard to carry. That's what it'll see using the same eyepiece versus the one sky. The telescope a little more than half, less than half of its size. Okay? Now you bump up the eyepiece here. Woo, looking good, huh? Yeah, and then the same view with the one sky. It's pretty good. The craters real nicely, and the picture will take really well. But yeah, and why this is more, but yeah, why this scaled in the bigger telescope is because it's bigger. It has a larger mirror, and it gathers more difference between like an old SD TV and a HD one. There's just more information presented to you. It's gathering more light, literally. Like big telescopes, they call them light buckets. It's like a thing. They kind of look like cannon, but you're not going to say light cannon because they're not shooting light out towards the sky. I guess they're kind of shooting it into your eye, but still, whatever. Light buckets. The thing is at this magnification, this is roughly, it'll actually tell you here, it's just nice. Magnification 100 times. Yeah. You start to magnify more, so you take in another eyepiece. Like this is a 9 millimeter eyepiece. It's a 2-inch one, 2-inch wide. Okay, there's two different types of eyepieces, big and little, basically. Bigger ones tend to work better with bigger telescopes. So yeah. So what happens if you put that 9 millimeter in? Woohoo! It's a very nice view, but now the moon starts to drift a lot faster as you're looking at it. We got this locked in Solarium, so you're not going to see what it looks like for it to slowly drift out of your field of view. And if you wanted to go real ham on this, I don't have it. If you zoom in like where you're gonna actually go, we're not gonna do that today, but you can like zoom way down to like different craters and stuff. Here's another tip: if you want to do that, wait for it to be like a at quarter phase or something. You want to see like detail along like the ridge of it. Full moon washes out detail. It's not intuitive. Go look at a full or almost full moon. Honestly, wait till it's like halfway point. That's kind of, I love looking at it. But look at it in every phase. It usually comes with 2 eyepieces. There's the regular size one. It's either 25, 26 millimeter or 32 millimeter. And then there's a little one with like a tiny little itty bitty hole. I don't know if you can see it well here. And those are usually like 10 millimeter or 12 millimeter. That's so they can say the telescope. Sometimes they put in one that's almost like a very tiny hole and it's like absurd millimeter view. You can't see anything through it. It exists so the marketing on the box and like, oh, looks there's something 400 times. Like, guarantee you put that on and look at something 400 times, it's gonna look terrible. Unless you're like in the high desert and you got a nice telescope. But unless you have a motor drive, it's gonna do the same thing. The more you zoom in, the faster stuff moves through it too, unless you got a motor. So that's why I kind of like to see it. I don't like to move stuff constantly. I don't have any motorized equipment for the most part. So I like to just kind of enjoy the view, wide view. But anyway, as you can see, this is kind of the, this is your basics. So this is what different telescopes will see depending on your setup. Yep, there you go. So yeah, Nikon again. And then big telescope, small telescope. You know, and then let's get out of this view. This eye. You kind of look like this. Yeah. That's cool. They have like an optical effect in Solarium. I don't know if you can see it online, but there's like a little ring around the moon right now, which if you got any mild clouds, that's another fun thing to look at when you go around. Is to look at the you know what? This has gone on longer than I thought. I'm having a good time. I don't think anyone's even on the stream. There is one concurrent viewer. Pretty sure that's me. But I am practicing. So let us advance time a little bit. And I'm old. So if I'm going to advance time, control. Ooh. Uh-oh. Oh no, I messed up. Subtract 1. Oh. Yeah. Okay, so we're right before. We're in the southeast. Let's look. There we go. Mars. So Mars will be up actually pretty early. And actually you won't be able to Mars. It's not until later this year. I'll show you. I'll look into Oculars right now. You wake up. This is 3:30 in the morning. Mars will be up looking pretty good by then. This is the view for binoculars. Big red star. Bright red star. Here's the thing with star charts. You're looking through, the sizes just indicate brightness. They won't actually be different sizes for the most part. To get some other deep sky objects, that is an advanced lesson. But yeah, you look through the one sky, still going to see a bright star. You're not going to see any detail. You're going to look at a 15 millimeter, 9 millimeter, still not seeing much detail. You'll likely see it at this point, zooming in as like a red orb, but you're likely not going to see polar caps or whatever. Let's switch to the Sky Watcher. You see a little bit of detail then. See a little bit of sky of polar cap action maybe, and that's like zoomed in pretty far. It's going to be traveling across this in probably a minute. Yeah. Later in the year, Mars gets way closer to Earth, and this will actually expand quite a bit in size. That's when you hear like Mars is going to be the size of the moon. It's like it's not going to be the size of the moon in the sky. Bigger in a telescope. It'll look a lot brighter to your eye, but in a telescope you'll actually be able to make out some detail. So for like 100 years it was kind of a thing where astronomers would wait and look at Mars every 2 years, and mostly Mars is pretty amazing in their sky. You can't look at it all the time. I mean, you can look at it all the time, you're not going to get detail out of it most of the time because it's so small and usually pretty far away from us. So that's Mars. Not looking so hot, but rising up before Mars, and maybe around midnight, if not earlier. Let's actually check that out. Blah, blah, blah. This is rising in the east-southeast. Oh, what was that thing again? Let's go back an hour. Control minus. Bop, bop. Yeah, there we go. Look how they all kind of... Well, Saturn and Jupiter are close together, and they're way far apart than Mars. Mars way more east here, and Mars, Jupiter way more closer to the south. Anyway, you want to wait. This is 12:30, so they're going to rise around midnight, 12:30. Jupiter, well, almost as bright as Venus was. So what will they look like through binoculars? Let's look at Jupiter. And here's a tip. Everything in astronomy looks better the higher up in the sky it is. So wake up in the morning before the sun, and then look at these two. It'll be a lot better view. Compare and contrasted views. Have fun with it. And for all these objects, you don't have to worry about adapting your eye to light, really. They're all so bright. Galaxies and stuff, you do need to do it. Anyway, let's take a peek-sees through the oculars here. Let's go down to Nikon. So, here's the thing. You see the little star here? That's one of Jupiter's moons looking pretty good. So let's go to the one sky. That moon looking pretty good. You may have noticed that the moon kind of shifted position. When we switch from binoculars to a telescope, this mirror flips the image. So then looking at it through there. Oh yeah, see Callisto and Ganymede. Let's zoom in a little more. Boom, boom. So if you're looking at Jupiter through the Skywatcher and through a large telescope, you'll see a couple of moons real easy. And even binoculars reveal a couple moons. And I've got my settings a little boogered up here. They shouldn't be this bright and big, the moons. So they're obscuring that you can see a couple of moons really close together, which is unfortunate. But yeah, so you have to use the biggest eyepiece and smallest field of view eyepiece on Jupiter. That's true with pretty much everything planetary, except the moon. The moon you can see detail right away. With Jupiter, honestly, with a 15mm eyepiece and the Skywatcher, I've seen stuff pretty well. I just think I tinker with some settings in here to adjust that. Anyway, since we're looking at Jupiter, let's look at Saturn through the binoculars. Now, here's an interesting thing. I've definitely seen a hint of Saturn's rings through binoculars before. Can't definitively say it. It looked a little squished. You can see moons. It says somewhere. There's a couple other moons highlighted, right? That's with the telescope. That's your view of Saturn through the binoculars, and Titan's not out big enough yet. So let's go to 32mm in the one sky. There we go. It's a little blurred out, but you can definitely see the rings here. I'm just going to bump it up a bit. There we go. I'm going to adjust everything here. What a shame. But you can see there's a lot of moons around Saturn, and they're a little funny. My apologies. You would certainly be able to see the rings with anything more than binoculars. And even with binoculars, if you got real good vision and large enough pair, 10 by 15 binoculars, 15 by whatevers, even 12 by whatevers, will probably see the rings. Because you can kind of make them out in 10 by 50s, kind of, depending. But yeah, these Saturn and Jupiter, they're going to actually move together every month, closer and closer, and in December, around Christmas, they're actually going to be in the same field of view for a telescope. In the next few months, I should know enough about how to manipulate Solarium so we could actually do a preview of that, with it looking actually good. Anyway, for today, these are just some basic stuff. Maybe we'll look at some other stuff next week. Way over what I thought I would do, and I'm pretty sure I've talked to mostly myself, but it's lovely to have anyone here who's joined or is watching a recording. Hopefully this is evergreen, so, you can get a little bit of a sense of what to use. Now, let me see here. Now I'll transition back to this. Okay, anyway, I hope a lovely time looking at my ghostly frame. And yeah, thanks for watching. And I'll be back next Friday, and I'll do some other astronomy stuff. Oh, anything else on the news? If you heard anything else about the asteroid or whatever zipping by, it's going to pass well past where the moon is. It's not a threat whatsoever, at least the next few hundred years. Almost all the time. They're not threats. So, with that being said, I'm Dave. Thank you for having fun with me in Star Time. And take care. Talk to you all later. Mm-hmm.